Hey, what's up guys? This is a tutorial that goes through one of the scripts I recently wrote. It is a tool that converts any selected edges in Maya to an icon. So as a quick example of this, I'm just going to select a bunch of edges, make it diagonal, make it really tough, hit the button, and it converts it to an icon. It's one continuous curve that can be used when rigging. So an example of this would be right here on the elbow. Let's say you need an icon on the elbow. It will fit the geometry perfectly because, well, it's made of the geometry. So another one on the wrist, wrap it around the waist, let's say. So this is an example. Any selected edges, as long as they're connecting, will turn into an icon. So another example, hit the button, boom. So when I first had the idea to do this, I realized that there were basically two different options. The first thing that I thought of was to create or to convert each individual edge into its own linear curve, and then I would parent each of those curves together. This is the result. It looks harmless, looks fine, but if you look in the channel box, you have all these shape nodes because each one of these is individual shape and it parents those shapes together. And while this is just a cube and there are 12 of them here, I can't imagine how many there would be if well, there would be a really long list. If I did something with, 300, 400 edges, something a lot more complex, which it happens. So I was stuck with going through the process of, well, basically writing a script that does it the same way that we would do it manually. So just to do a quick demonstration for those who are not that familiar with this. So create a linear curve, or start creating a linear curve and just start snapping it to each of the vertices. So typically when we're doing this manually, we have to go through and find that route that goes around to each of these and it connects them. You can overlap them, Maya doesn't care, just as long as they are all connected at the end. Finish these up. So this is something as simple as a cube. Imagine if it's something a lot more complex, like going around the ankle right here, doing like 3 levels of edge loops going through there and then connecting each of them. It's going to be a lot more complex than this cube was, but for the sake of example, this is the process that you have to go through. You have to find that route that connects each one without cutting through the middle, without going diagonal, anything like that. So this turned out to be a lot more complex than I originally thought it would be. But to dive in, I was able to find a nice process. Now this script, this is what I ended up with right when I finally got it to work. This is not cleaned up. I left a lot of these prints in here just so that you could see the process that I went through. So in a nutshell, what this script is going to do is create a list of coordinates, and it will run the curve command right at the very end, and this is the list of coordinates, this chord list. And basically it's the world space location for each vertex in the order that it would be created if you were doing it manually. So let's say I was going around the top, it's going to have the coordinates for this, and the coordinates for this, and then this, and then this, and so on. So it would just run the curve command, run that coordinate list, and build the curve. So to do this, as I demonstrated earlier, if you select the edges, it begins the script. So the very first thing on the list is I capture the selected edges, and the first loop is going to convert it to vertices. Basically, it starts with the first selected edge, and it converts it to vertices. Since each edge consists of 2 vertices, it comes up with a list of combinations of vertices. So here's an example right here. So this is one section. It has two vertices, human body shape 3014, human body shape 6131. Those two vertices make one of the selected edges. So it comes up with a list of these lists, these combinations. Second loop takes that list of combinations and it adds a little bit to it. What it does, it gets the location for each, the world space location for each of those vertices, and it appends that data to the list. And then it turns that list into a list of lists. So an example of this right here, this is a little template for it right here. So this is just one section. There's the first vertice, which is what we see up here, this guy, and the location for that, and the second vertice and the location for that. And it basically creates a list of these templates. So you can actually see right here, you've got the vertice, location, location, then it breaks it and starts another section, vertice, location, location. Second section, first section, and this list continues on and on and on, one for each edge that was selected. So if you have 100 different edges selected, there are going to be 100 different sections like this. So that means that, well, since two edges, these two edges right here, there are 3 vertices total. This edge consists of vertices 70 and 71. This consists of 60 and 71. As these lists go through, if you think about it, there are going to be a lot of duplicates. I mean, 71 is going to occur in a lot of different places here, or in multiple places here, because, well, it's in this edge and this edge and this edge and this edge. So it's actually going to show up 4 times. Each, the majority of the vertices actually show up 4 times in this list. So what I did, like this list is actually this is the data that that the script is going to be feeding off of the entire time. So what I did was I created this main vertex list. This consists of 2 integers. The first integer determines which section it's going to be reading off of at that given moment. So, right here we have 2 sections. Let's say this is, on this first section right here. So it's going to be reading one of these 2. The second number determines which one of those 2 is actually the main vert. The main vertice, let's say I'm working my way along here, just working, creating this curve. 23 will be the main vert, 22, 20, as I'm creating, building this curve through all these edges, whichever one I'm on is the main vertex. So this second number, since it's telling which one of the 2 it's going to be reading, this second number is either going to be a 1 or a 0 at any given time. It will never go above 2 or above 1. It will never go to 2. It's just the first one or the second one. So to dive in, this main loop starts here and it actually goes through the very end. It has several other loops in the middle of it, but this loop is the bulk of this whole script, and this is going to be appending each of these coordinates to the list in the appropriate order. It starts out with 0, 0, the very first combination, the first vertice in the first combination. Append the coordinates to the list. Those are going to be the first things in the chord list. Then it's going to swap the second digit to the opposite of what it is. So if it is at 0, it switches it to 1. If not, it switches it to 0. So let's say, this is the main vertex. The first number is 0, right? So we're going to be reading this very first section in the list. It's going to append this, and then it switches to the other one, because this is now the main vertex. This one is no longer needed. This is the main one. Like I mentioned earlier, since they're copies, this vertex is this might be the second one in this section, but it's actually going to be the first one in a different section. Or it will be one of the ones in a different section. So if we append this Now, when we move on to the next section that shares this vertice, it's actually going to be appending this location twice. So at this point, what we need to do is go through the list of these combinations and find another combination that contains 5328. And we'll get rid of this combination right here because we no longer need it. We've already appended its location. We no longer need it. So it swaps to the other number, 0 to 1 or 1 to 0. So it jumps to the other one of the two. And it starts another loop within this loop that goes through each of the combinations in the list, and it finds another combination that shares that second number. So like I said, it's doing this section right here. It appends these, then it switches the number to the other one. So this is now the main vert. But instead of appending these values, it's going to find another section that shares 5328. So that's what it does right here. Now, the majority of these combinations is going to be able to say, you know, okay, well, this vertice is in the next one. So it just switches to the next section and it gets rid of this. But there will come a point where there are no other combinations that have 5328 in them. So what the rest of this section does, basically from here down to here, is it finds whatever, well, it takes whatever the first vertex in the first combination is. So in this case, let's say it's 3. And it takes whatever the current vertex is, so let's say it's 36, okay, and it finds all the surrounding vertices to the current, or to the main vertex. So in this case, it'll be 25, 35, 47, 37, and it'll measure the distance between each of those vertices and the first one on the list. So like I said, in this situation, let's say it's 3, it's going to get the distance in world space, distance between 3 and 25, 3 and 35, 347, 337. Whichever one of those 4 or however many is actually surrounding the main vertex is closest to that first one, it's going to jump to that next. Because, well, like I have said, it doesn't have any direct, combinations to complete. So hopefully it's hoping that, hey, maybe 25 will, be in one of the remaining connections. But if it's not, then we're at least working our way toward one that we know is in a connection. So it's going to jump over to 25. So what it needs to do is append 36, append the location of 36 to the list, because, we're moving along. We get to, we're creating this curve. We get to 36. Okay, we're stuck. Okay, we're going to move over to here. So it's going to append the location for that, for the main vertex. And what it's also going to do is it's going to set up basically a temporary vertice, or a temporary storage. So whatever vertice, in this case it would be 36, well, 24 or 25, since it's jumped over to 25. 25 is basically going to become the new temporary vertice, because, well, we have to take that section out of the list of combinations so that we can move on. So it has this temp store, a new variable, where it just stores, we're on 36, so it says 36 is temporarily the main vertex. So this whole process down here is going to determine which of these 4 vertices is closest to the first one on the list. That's what all of this does. So this section right here, this is the first part of the rest of this. This converts the current vertice to all the surrounding vertices. So just like you would do in Maya, if you've got vertex. If you've got this vertex selected, actually I was saying 36, so I'll just select that. So if 36 is selected, let me get rid of this. If 36 is selected, and then you want to convert it to the 4 surrounding vertices, well, yes, we could technically just jump out, but then we're actually going to get these ones in here as well, the 48, 46, and those are not direct connections. So we can't do it like that. So what we would have to do is convert the selection to edges. So these 4 edges are selected, and then convert it back to vertices. And that is going to select these 5 vertices. We obviously don't want 36 again because, well, we can't connect 36 to 36. That would be 2 sets of coordinates on top of each other. So what this section here is doing is converting from vertices to edges, and then from edges to vertices. So doing exactly what we just did, it now creates a list. In this case, it would create a list of these 5 vertices. And since in this case 36 is in that temporary storage variable, what this is going to do is it's going to remove the temporarily stored vertex from the list. Because this has created a list of vertices, we're going to remove the one that's right in the middle, the original one. So we now have a list, in this case, of 4 vertices. What it's going to do is it's going to get the distance between those. It uses, some fun math, square roots of a bunch of awesome stuff. And it creates another temporary list with those distances in it. So at this point, basically we have a list of 4 vertices, and it's actually going to be similar to this list up here, where it kind of follows this template right here. So where it has the first vertice and its location, second vertice, its location, third vertice, and it just keeps going, third vertice, location. But instead of the location in world space, it's actually the difference between, that vertice and the first one on the list. So now it has this list, and let's say, since we're right on 36, and we've got these 4 vertices, let's say the original edges that we selected were like that. So it kind of splits it down the middle. Obviously, we're not going to need an edge to go over to 35. We're not going to, we're not going to need to go from 36 to 47. Yeah, we would need to go to 48 to 47. So 47 is in the list somewhere, but it's not going to be able to make this connection. So it goes through each of the vertices that are selected, each of the surrounding vertices, and it takes out the ones that were not part of the original selection of edges. So in this case, it's going to take 35 out. It's going to take, 47, it'll technically leave it in there. A later part will take that out because there's not a connection there. But in this case, it will take 35 out of those 4. So at this point, with the original 4 verts, it's going to take 35 out. So I'm just going to deselect this, and remember we've already taken 36 out because that was the original one. The only 3 remaining in this situation are 25, 37, and 47. So this last section, it takes all the remaining vertices, which in this case is 25, 37, 47, and it figures out which one of those 3 is actually closest to the original. And like I said, in this situation, let's say it's 3. In this case, those 3, the closest one is 25. So it's going to make this temp store the name of the vert and its location, and it will jump back to the beginning of the loop. So now we're back to where we started in this loop, where it's going to find a combination, or one of these combinations that has that temporary vertice in it. Whatever, in this case we came up with 25. So it's going to try to find a combination that has 25 in it, and it will take off from there. It will continue from there. So since this is a loop, it's going to keep going through this. Let's say it finds a connection, so it jumps back to the beginning. It finds a connection, so it jumps back to the beginning. It finds a connection, it jumps back to the beginning, so on and so forth. Near the end, we're going to have, let's say that I've selected all of these edges right here. There's going to be a point near the end, typically, where there'll be, 2 vertices right here, 2 vertices right there, 2 vertices right there. So there aren't going to be, there are only going to be 3 more combinations, let's say, in this entire list. So it's going to be going through this loop all the way to the bottom over and over and over, because it's just trying to work its way over to here, makes that connection, okay, trying to work its way over to here, make that connection, work its way over to here. But this is the process, and every time it makes a connection, it takes one off. So once this list of combinations, once there are none of them left, it's done, and it stops. The loop is over. It creates this command, this curve command, because this chord list is complete, and we have our tool. It then centers the pivots, and it looks like center pivot is not in this copy. It's in the one over here, and it is in the one that I posted online. But it creates the curve, it centers the pivot, finalizes it, boom. So I hope this all made sense. If you have any questions, you can leave comments. If you have any suggestions on better workflow, I mean, I really haven't been doing this all that long. So if you have any suggestions on better workflow, you can definitely, I'm definitely open to constructive criticism on all of this. So I hope you guys enjoy. If you have any issues with the script, let me know. Leave a comment. I'll make an update if there's an actual issue. So enjoy.